So, isomerism. What do we mean by the term isomerism? In chemistry, some compounds are observed to have the same molecular formula, but their structural formulae will be different. So, we make reference to such compounds as being isomers of themselves. In other words, when two or more compounds are observed to have the same molecular formulae but different structural formulae, such compounds are said to be isomers. So simply put, isomerism is a phenomenon whereby certain compounds are observed to exhibit the same or have the same molecular formula, but they show different structural formulae. In the alkane family, methane, ethane, and propane do not exhibit isomerism, but alkanes and above exhibit isomerism. So, having seen what isomerism is, let us now take a look at how to create isomers of a given compound. You may be asked, for example, to create an isomer of a given compound or isomers of the compound. Or you may be asked a question which says, how many isomers does a given compound have? To answer such a question, you will have to create the isomers of that compound. So let us take a look at how to create isomers. There are rules that guide the creating of isomers. Rule 1 says we will have to take away the first or the last CH3 group in the chain. That is to say, in any given hydrocarbon chain, to create an isomer of that chain, the extreme CH3 at the left or at the right will be broken away. When you break it off, they will be attached to the middle of the chain, of the hydrocarbon chain. It is forbidden to attach that CH3 to either of the extreme carbon atoms that will be remaining. So when we break off one CH3 from either right or left side of the chain, the new compound that is left there, none of the extreme carbon atoms will take this CH3 that has been broken off. So the CH3 that has been broken off must be attached to the middle carbon atom. Any of the if there are more than one middle carbon atom, then the CH3 that has been broken off, that has been cut off, will be attached to either of the middle carbon atoms. That is the rule. So let's look at the third rule. The third rule says that for higher alkanes, where series of derivatives are possible, that is to say we may have up to 5, 7, 8, 10, 15 to 20 isomers, the last CH3 group attached to the carbon atom bearing the branch CH3 is never moved again. We'll get to understand what rule 3 is saying. If we have a compound like butane, as you can see, 4 carbon atoms, from butane we can get the isomer of butane, which is just one isomer. So when we get the isomer of butane, the isomer of butane is 2-methylpropane. So in a nutshell, butane has 2 isomers, butane itself and 2-methylpropane. So if you are looking at 2-methylpropane, from 2-methylpropane, rule 3 says that we cannot break off that CH3 either at the right or at the left. The CH3 there, we cannot break it off again to form another isomer. Why? The reason is that the extreme CH3s, as you can see, are already attached to the middle carbon atom that is bearing or carrying CH3 at the base. And that CH3 was the initial CH3 from butane that was broken off. So that is what rule 3 is saying. That CH3 at the extreme right, or even the one at the extreme left, can never be broken off again. It can never be moved. So that is the rule. Now let us proceed to looking at how to form isomers. Now, to form an isomer, it is important to note something. Beginning from butane, as we have it there, this is the structure for butane. As the structure for butane, hydrogen, 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 hydrogen. Now, the rule says that we must take away the first or the last CH3, depending on where you are counting from. If I'm counting from the left-hand side, then it means if I'm counting from the left, if I choose to come from the left-hand side, then it means this is my first CH3. And this will be my last CH3 here. But if I'm coming from the right-hand side, then opposite will be the case. If I choose to come from the right-hand side, opposite will be the case. So, let us look at how to form our isomer. How do we form the isomer? To form our isomer, the rule says we have to cut away the first or the last CH3 and place it at the middle of the chain. So let us take it for example that we are coming from the right hand side. So we are going to cut off this CH3. We are taking it away. This is CH3, so we are cutting it off. So to cut off that CH3, our compound will now become 3 carbon atoms. Hydrogen here, here, hydrogen, hydrogen. Now we are going to have this. This is what we have left. So this is our CH3. We have cut it off and it is here. Let us place it one side of the screen. Now what do we do next? The rule says the CH3 that has been cut off must be placed at the middle of the chain, not at the extreme of the chain, neither right nor left, but at the middle. So it means that this CH3 must come somewhere here. That is what it means. So let us do that. To do that now, we are bringing our CH3 carefully, carefully, carefully to place it somewhere here, getting attached to this middle carbon atom. But there is a problem. What problem is that? The problem is, looking at the middle carbon atom, it is already having 4 bonds. So how can we attach CH3 to it? That is where the problem comes in. So, it is possible. Now what happens is, in order to attach that CH3 to it, this hydrogen will have to give space. It will have to give its space up. So it leaves away. The hydrogen goes back to where the CH3 was cut out from. That is the rule. So they have to switch position. It's just like the CH3 now switches position with the hydrogen that was initially attached to the carbon at the middle. Don't forget, it is not necessary that it must be the hydrogen at the base. You can also attach it to the hydrogen at the top of the carbon. Either way is accepted. So what do? We only have to switch hydrogen and CH3. So they are going to be switched now so that you get to understand what we are talking about. So to switch the positions, we are cleaning off hydrogen and automatically our CH3 is coming on board. So our CH3 comes on board and that is CH3. So our CH3 comes in here. Now that our CH3 is there, sitting comfortably, hydrogen also goes over the other side to replace the CH3. So we have automatically formed the isomer of butane. So the name of this compound is now 2-methyl. It is no longer butane, but 2-methyl propane. This is 2-methyl propane. Now, look at rule 3. let's take a look at rule 3. As rule 3 says, that the extreme CH3 can never be moved again. This is what we are trying to say. Looking at the isomer of butane, which is 2-methylpropane, this CH3 here, or this one, can never be moved again. We cannot break them again to form any isomer. Why? It is because they are already attached to this middle carbon atom that is attached now to this CH3 that has formed the isomer. So for that reason, the extreme CH3s cannot be moved again, unless maybe we have more chains. Such chains can be moved. So let us take a look at examples where we can have more chains and we can move them again. So this is the isomer for butane. So it therefore implies that butane has 2 isomers. Butane has 2 isomers. What are the isomers? The isomers of butane is N-butane, that is butane itself, and 2-methylpropane. 2-methylpropane. These are the isomers of butane. Butane itself and 2-methylpropane.